Hello and welcome to Grafana's Big Tent, the podcast all about the people, community, tools and tech around observability. People and community, the same thing. Tools and tech, the same thing. And what we're doing. Okay, I'm here today. I'm joined by Donia, Charles and Bryan. Donia is a software engineer and works in community at Isovalent at Cisco now, and also co-author of the Learn Go with Pocket Size Projects book with some other people. Hi, Donia. How are you doing?
Hey,
Welcome to the podcast.
thank you. Thank you for the invitation. I'm so happy to see you again here.
Yeah, it's going to be great. How's the book? I love your book, by the way. I learn by kind of building things and actually doing things. And I think learning Go like that with these little tiny projects that you pick up and finish quickly while learning lessons. I think it's a great format for that. So I'm a big fan myself.
Thank you so much. Yeah, I guess that's the way I like to learn too, just to explore and get my hands dirty or have tiny projects. So that's how it came up on the table. And yeah, people are quite happy. They're saying that they're not so pocket-sized sometimes, but they're learning things anyway. So that's cool.
Well, big pockets, especially because your book's so successful. So that's fine.
Yeah.
We're also joined by Charles Korn. Charles, you're principal engineer at Grafana Labs, and you're working on the Mimir query engine at the moment, aren't you?
Yeah, that's right. Yeah, thanks for having me on, Matt.
Yeah, pleasure. Where in the world are you, Charles?
I'm in Melbourne, in Australia. So the other side of the world compared to all of you.
Yes, I went to Melbourne last year. Loved it. It's all right.
Yeah, it's a nice part of the world.
That background hiss that you just heard during the conversation comes from Bryan Boreham. Bryan, hello. You're a distinguished engineer at Grafana Labs. That's pretty good, isn't it?
Well, I like to think so. Well, maybe it just means I'm old.
No, it's not. It's good. It's because you're good.
Well, thank you very much.
Yeah. So in this episode, then, we're going to talk specifically about Go, but obviously it's the Big Tent podcast. We're at Grafana Labs. We care a lot about observability, and want to see kind of if we can give people a sense of things that you should be paying attention to when it comes to this in Go, mistakes maybe we've made in the past, and hopefully a lot of other useful bits of information along the way. Maybe we could start out by, if we were starting a brand new Go project today, all four of us here would get fired because of this podcast. It's just imaginary. But this podcast, let me tell you, it doesn't go well. Okay, we all get fired for whatever reason, probably Donia's fault, and what we're going to then create a new Go project. What do we need to think about when it comes to observability? What should people care about if you're starting a project from scratch in Go?
I would say that I would go simple to start with. We know that we are always refactoring along the way, that priorities change like real life. But I would try to go for standard libraries as much as possible because we know that they're stable and not going to be archived tomorrow, basically. I would go for also well-known libraries that are not standard ones, but they're used by most of the people and then well-maintained, even though we know that contributors are less and less in the open source world. I would also think about some standardization from the beginning, the way you want to put your data, your context, the way you want to trace, that kind of things. That's the basic, I would say, to start with.
Yeah. No, but I think that makes sense. I like your point that you're going to refactor. Things are going to change. So that's kind of takes a bit of the pressure off. It doesn't have to be perfect straight away. But what would you have? Charles, would you have start with metrics? Would you just have logs? Would you start with something and having profiles and things, or add that later?
I mean, for me, the thing I use probably most often, at least in the stuff that I'm working on at the moment, is logs. And from logs you can derive metrics if you really need to. So that's probably where I'd start. They're really easy to get started with. You can dump them to a file, you can dump them to the console, and you can start shipping them off to a system like Loki or something like that. I think if you're going to start with something, start with logs, and then as you get more and more sophisticated, add things like metrics and profiles as well.
I think that's quite natural, isn't it? That you would start with logs. I think I heard someone say, it might have even been Bryan in one of his talks, that the first thing you do in a program is log with the hello world. Bryan, did you say that at
You
all?
print out what I've got here.
Yeah, here. I put monkey. There is software running somewhere that just has monkey printed out occasionally in some edge case still. Just monkey in all caps. I had a friend worked at a place, and he chose a swear word just so it could grab his attention. And that did, unfortunately, not get spotted in review and did get into production. And I think he did get a little bit in trouble for that. But Bryan, so do you agree? Logs? Start with logs?
It's all good tips. Yeah, I think so, because it's, I don't know, for someone like me, it's very natural to just kind of print out. I mean, you start typing and you kind of probably think you know what you're doing, and then when it gets above 20 or 30 lines or something like that, you lose track, and so you print something out. It's done this bit.
Yeah.
But then when you turn that into a so-called real program, you need to make some decisions. If you're printing out 2 or 3 lines every operation that you do, then you can't do thousands or millions of operations. You just got way too many lines, and so segregating them into debug logs, info logs, error logs, that's a pretty common pattern. Although one which the Go standard library did not agree with.
Yeah, you just get kind of flat log line, don't you? There's nothing really special. Of course, there's the new slog structured logging. Would you reach for something like that straight away?
Yeah, I think slog's very good, and gives you that little bit of extra flexibility in log levels.
Yeah, and also lets you have you kind of have key value pairs, but it's still in a log line. But for anyone that doesn't know, there's structured logs. So it might say
that's a kind of thing that divides people, like the choice of editor or something like that. But whether you have an extremely structured log line, maybe output the whole thing in JSON, for instance, which I personally don't like, because it just seems to get in the way of understanding when you have to kind of fight your way past all the curly brackets and the escaping things and so on. So I tend to just have a line of text that's meant for humans to read in my logs. But it's certainly a good point. So I would kind of structure the conversation like, you start out by just printing some lines that are meant for humans, and then you realize you've got way too many lines, and some of those go to metrics, because you just, the interesting thing is just to count it. And then if you can go to traces, if you can, if you have the infrastructure to set up or use a SAS maybe tracing system, then that's kind of like logs, except they all link together.
Right. Yeah, having a trace ID in a log line, is that enough to say that these log lines essentially belong together?
Yeah, it can be, but tracing adds that explicit parent-child relationship, and everything's always got a beginning and an end. And so I think tracing is kind of the superpower of figuring out, in a complicated program, of figuring out what happened. It's not very good for an audio medium to sort of start describing a Gantt chart visualization. But,
yeah, you can try. You could describe a flame graph, though, couldn't you?
Well, flame graphs are different. Flame graphs are not ordered by when things happened, for instance. So a Gantt chart is ordered left to right by the time that things happened, and then top to bottom in a sort of a waterfall of what triggered what.
Yeah.
And you can see patterns, in that visualization. You can see when there's a very linear sequence of things. I'm waving my hand, for the benefit of the tape.
Yeah.
I'm waving my hand in a diagonal motion. You can see when a lot of things kick off in parallel. You can see when a lot of things end in parallel, which might mean that they're all bottlenecked on a mutex or something like that. So yeah, that time-based visualization is why I call it the superpower, to really see what's going on. And flame graph. I mean, I love flame graphs. Flame graph is an amazing idea, but part of what it does is it dispenses with the time axis and says we're going to try and show you what's important, what there's a lot of. We're going to use the x-axis to mean quantity rather than time.
So the idea being it's spending more resources in that bit, and therefore, if you're going to optimize something, go for the big hanging fruit. Would you say? I suppose so. So you mentioned that you would do that only in advanced projects or complicated projects. How do you know when it's time to reach for tracing?
Well, for myself, I mean, I said 20 or 30 lines, but it gets complicated. So my bar is very low. My ability to concentrate on things is quite poor. But it also depends because tracing is quite a complicated thing, or people find it complicated to set up. And whereas logs, just stick it in a file and then read it. It's orders of magnitude different. But tracing really comes into its own when you have multiple bits in what you call a distributed system, multiple front end and back end, or multiple bits of back end or something like that.
Right, where you pass the same idea around to everything because it's related, and then they're all logging or they're all like reporting using that same ID, and that allows you to then tie the whole process together across all these multiple systems. Which is is very cool, and of course makes sense at scale. So we talked about like sometimes you just want to count something that's happening in logs and turn it into a metric. I just want to dig in on that so that people really understand that, because it turns out to be really quite powerful. Can we think of a specific example of where a log is turned into a metric, and what would you use that for?
I've got one example from last week, actually. So, yeah, I mean, we run
Have you got anything more recent, Charles? No, well, last week's fine. We'll settle for that. Go for it.
So, yeah, we run a bunch of Go services at Grafana Labs. And, yeah, like, unfortunately, occasionally they panic. And they dump the trace to their logs, and that gets logged to standard error, and that gets picked up by our logging system. And it's really useful to be able to show that on a graph. How often are things panicking? And so, yeah, we actually have a system where like it'll look at the logs, count the number of things that look like a panic, and turn that into a metric. And then we can alert on that metric just like any other metric. And that's really helpful. And yeah, it means that we can get paged when stuff breaks.
Yeah, so you literally then get a graph that shows you how many panics you're having.
Exactly.
And you can have alerts on that. So that is quite interesting. So you sort of like will tolerate some panics. Will you?
No, we get paged for every panic now.
Right.
Because yeah, we had a couple of issues where we weren't doing that, and yeah, things broke. So now we pay attention to that stuff a little bit more.
Yeah, I see. That's not the same as errors, is it? Like you might have a tolerance for errors, right?
Yeah, exactly. We use SLOs for that.
Yeah. Yeah, that's very cool. I did work with somebody who they had so many alerts firing that they weren't. They basically then had a metric to count how many alerts were firing, and that is what they would then alert on. So they were happy with like thousands of alerts firing, but once it reached a certain point, it's like, nah, come on, that's too many now. And then they would. So that's kind of like, yeah, amazing. But I do like the idea, and it's one I think people that are sort of new, or if you haven't done much observability yourself, this idea that, and we obviously have technology that does this very well. There are others available, but you can, create this numerical data from what's happening inside your log data, especially if it's structured logs, although of course I think Loki does some good work of extracting meaning from even unstructured. So that's very cool. So does Go help here? Does Go make this easy, or is it tricky in Go? Like, when they created the language, testing was like a first class concern. Was observability a first class concern? And did they do anything good or anything not good?
So they didn't do a lot, I would say. The Go standard libraries had a very, very simple log interface, arguably too simple. So everybody replaced that with some sort of third-party thing. But really nothing for tracing. I mean, they didn't even have context in the first few releases of Go, and then when they did add context, you have to remember to put it in yourself. So that's what lets you thread a trace from one call to the next, and therefore let you do that visualization to see what called what. And again, really nothing for metrics in the standard library. There are some internal metrics inside the Go runtime, which are really, really good. If you need to know that kind of thing about say how the garbage collector is running. But yeah, I think that's certainly originally was kind of a TBD, and then they added structured logging, that slog, which I think has pretty much taken out most of the reasons why you'd use a third party. So Go's, it's pretty good now for logs, and then it's got context which lets you do tracing, but you still have to bring something in, like the OpenTelemetry is the sort of standard. Used to be a thing called Open Tracing, but they sort of folded it into the new standard OpenTelemetry. So that's what people should be using for distributed tracing, and metrics. You're still left with a third. You need some kind of third party provision for that. Mm-hmm. And we could get into that. I just remembered. I mean, there's another kind of tracing built into Go, which is called execution tracing, or I usually talk about Go tool trace, which is what you type in if you want to use it. And that's a very, very detailed trace of what's going on. So the distributed tracing that I was talking about earlier, that's intended for production systems. You can capture millions of requests over a day, say, and get a picture of all of them. The Go tool trace is more intended for capturing like 5 seconds of what happened in your program, or maybe a bit more. And they're certainly working on reducing the overhead, but it's a vastly different level of detail. So that is built into Go. The Go tool trace, the execution tracing, I would describe that as extremely cool. And if cool things attract you, then go find a video, where someone's demoing that, because it's quite remarkable what you can get out of it. It is hard to get into. It's very hard to understand at a glance what's going on in that tool.
No, yeah. So on the tracing with the context is an interesting point, and this could be our first gotcha warning, because it's possible, so the way it works, I guess, is when the request comes in, maybe there's a trace ID in a header or something, and you'll have some kind of middleware or something will grab that and put it into the context, into the Go context as a value, I suppose. And then that gets passed through all the execution everywhere, and then anything that's logging or contributing kind of data, we need to tie it back to that kind of transaction or that particular operation. The trace ID lets you do that. So if you kind of just use context background suddenly in your package somewhere, or you just don't respect the passing of that context, I suppose that breaks the tracing, doesn't it?
It absolutely does.
So there's first gotcha warning.
Yeah, try to pass context. I wouldn't say absolutely everywhere, because there's a little bit of cost in terms of extra code and runtime and so on. But pretty much, except at the very, very lowest level of the very inner loop of your program, you might want to think twice about it. But pretty much everywhere else, you will benefit from passing a context, because you can trace things, you can cancel things.
Mm-hmm. Do you wish it was built in, like beyond just having it as a value that you pass around? Do you wish it was actually baked in somehow to Go?
I do. I mean, there are caveats to that, but life would be so much simpler if you could just ask the Go runtime, where, how did we get here?
Yeah.
Yeah, I just wanted to add that depending on the architecture of your project, but for example, if you're using like domain layers and domain architecture, it's very easy to identify where you should put your context depending on where you are, like in the different layers. And I feel like at some point, that you're so like domain and low level that you might not need the context anymore. You're just like playing with data, let's say, basically. So I would say that above, that you have to use the context because you're playing with the request and all the things that you want to trace, definitely. There is actually one rule that we define in the book about context is like, pass it almost everywhere, yes. And if you don't need it, just have the blank operator. And maybe one day you're going to use it.
Right.
So you don't have to change the signature of your functions all the time.
Yeah. Yeah, I find that often that I want to do more logging while I'm sort of still building the thing. And I tend to build in the wild a lot of the time. I'll have something that's alongside other code. I'll have like new code that's not yet being touched, but we can test it in the sort of real world. And then later, maybe I'd tidy up some of that logging and things where I don't need it. But that is a nice trick. And the little underscore trick tells you, yes, it's an argument, but we're not going to use it in this particular take on it. So I think that's a nice tip, top tip. Charles, what were you going to say?
I was just going to go back to Brian's point about, like, it'd be really nice if it sort of happened automatically and you didn't have to pass the context around. Like that's what happens in a lot of other languages, right? Like, .NET ecosystem, JVM, like you can do things like that and then it magically does it based on the thread. So yeah, like I wonder if something like that could be done in Go, because that'd be really cool.
Yeah, but I suppose the Go's philosophy really is a kind of against the magic and against hidden stuff happening.
It's true.
Like that.
It's true. Yeah.
Yeah, and so I don't know, but I have seen some proposals where you could have some kind of new functions where you just say get the context. There is some complexity around. Sometimes you do want to change the context or add to it, and sometimes you do just want a completely different context for some reason, don't you?
Yeah. Or you don't know like what the heritage of that thing is, right? Like you've got a pool of Go routines servicing requests. It's not clear what the path is into that one, and what the link is for that trace.
Yeah.
Yeah, we just have to sort it out.
Just sort it out.
Yeah, it's one of these things you have to. The designer of the system has to kind of bear that burden of understanding what Charles was talking about. If you have a pool of threads, really. I mean, yes, it'd be Go routines in Go, but the point would be to try and run a bunch of things in parallel, and tracking where did those come from, what is the context for that is something that ultimately the designer of the system has to understand what that means and where that goes. And so the choice that Go has right now is you just always have to do that. You always have to track the context.
Yeah.
It's a little disappointing.
Well, yeah, but it has the benefit is you really can see what's happening, which is nice. And errors has the same thing, right? So same thing. Some languages have exceptions, or they have an alternative kind of chain for managing and handling errors. In Go, they're just normal values that you return. Does that get in the way as well, or is that useful? How do we feel like that design impacts when it comes to sort of observability?
One thing I do miss sometimes from like coming from other languages, like you've got an exception type, and like each of those exceptions is a particular type. It's a file not found exception or a network error or whatever it is. Whereas with Go, most of those things are just strings. And so like if you want to do any kind of analysis, like how many file not found errors did I get? that can be quite tricky in Go because like they're just a whole bunch of strings. Each of the strings might be slightly different. Maybe some of them are prefixed to something, some of them are prefixed to something else. Some of them have the file name in them. You could have some way of categorizing them and merging those into one group, and that can be quite tricky with Go's sort of focus on strings, I guess, or like sort of stringly typed errors. But at the same time, it makes it really simple to create these really rich errors that are really easy as an engineer trying to solve a problem to get that context of what's going on. It's a bit of good and bad.
Yeah, and you've got to, whatever you come up with as well, it has to be easy to maintain. It has to be easy as people come in, new people come and add things. If you've got these kind of complicated rules that you're following, or even special error types can be kind of tricky. You have to then do the work of making sure that everyone kind of follows this as well, don't you?
Yeah, so I started my career with Go, and for me it was very natural to have error types, and that was like normal to create new types of error if I had something specific, and it was a reflex to just check if there are the type of error that I wanted already, like in the library where I was. And I did 1 year of Java in a company, and I was playing with exceptions, and like I was like confused actually. I was like, I want to define my own error type in that case because it's something very specific, and I want to type it for that type of library that I'm dealing with. So that's very interesting that Charles is talking like about the way exceptions can be in general more easy, maybe, let's say. But I find that error types in being more granular is easier to read in the code and to understand when you're debugging too.
Yeah. And then what happens to errors? Do they just get logged out, or do we count them? Does it depend?
Yeah, I guess that in our cases it was more for debugging purposes, and it was not for counting. So it was at the time where we were dealing with processing of satellite images. So we wanted to check like a massive, basically, processing in each step what was going on. So it was not about counting.
Right.
So in Go at the moment, because an error is just another value, you have to write the code somehow to if you want that in your logs or your traces, or you want to count it as a metric. You're going to need some code somewhere that does that. And I mean, certainly at Grafana Labs, we put that in a framework imaginatively called the server framework, which is part of our DS kit, distributed systems kit library. But yeah, the again, it's one of these things that is not built in, is not kind of batteries included in Go. That you have to have some code that figures out an error happened.
Yeah. So then profiles. Go? I know Go has pprof. What is pprof? Charles, do you know what pprof is?
Sure. So it's a tool that allows you to measure the performance of your Go application. And it can show you a bunch of different profiles. So the ones that I use the most often is the CPU time. So it's literally just how much time is spent in different functions. And that's presented usually in a flame graph, like Bryan was talking about before. And the other one I spend a lot of time looking at is memory consumption, like peak in-use memory consumption. Right. And again, like it's exactly what it sounds like. It shows you which functions have are holding the most memory alive at any one time. And yeah, that's really useful for working out how to cut those things back, make things faster, make things less resource intensive. And yeah, this is really cool. So you can run this as part of the Go testing command. You can run Go test and ask it to spit out a profile as part of that invocation, and then you can load it up into pprof, explore it either in the web browser or in your terminal, and yeah, have a look at that data and use that to make optimizations to your code. Or you can send it off to a continuous profiling system and then aggregate that from production, which is really cool because then you get to see how your application behaves with real users throwing real traffic at it, and all the weird and wonderful things that customers do.
Yeah. Okay. So do we get that for free then? You can just run the test and ask for the profile, or do you have to go in and do something special in the code?
There's nothing special in the code. You have to pass a command line flag to the to go test, and then it spits out the profile file.
Yeah, so that's very cool. That's helpful. And usually with things that are sort of out of the box like this, they're good for the basic case, but then if things get more advanced, they become like kind of a pain sometimes. Does that happen in this case with profiles?
At least in my experience, like I find profiles really useful. Like I would look at profiles every couple of days, at least with what I'm working on at the moment, which is really cool. And like something that is quite nice is that you can actually set tags on profiles. So just like you add tags to metrics, like add labels to metrics, or add like structured metadata to your logs, it's actually possible to add tags like a trace ID, for example, to profiles, and then it will be propagated with that profile, and you can then do things like show me the profile for this particular request. So if you've got a really painful, really long running request, and you've captured the profile for that, you can go and look at that profile and understand where it was spending its time, which is great if you haven't got tracing, for example, that shows you where the time is.
I have a question, actually. I've always been very intimidating at the beginning of my career by pprof, actually. Do you have any advice for someone that would start with it?
I was very intimidated as well. And actually, when I first joined Grafana Labs, I went to a session that Bryan ran that introduced me to pprof.
That's why you're intimidated.
So,
Brian's a formidable. Brian's a scary man.
And you may be able to find a version of that on YouTube. Actually, I've given one or two talks over the years. I basically search for my name on YouTube because it's fairly unique, and see if I'm talking about profiling. There's a lot of information there, and I was just thinking to myself, actually, there was one or two gotchas. And the big one, I think, that catches some people is that they dive into CPU profiling when they don't actually have a CPU problem. They're not limited. They're not running out of CPU. They've got a program that's slow, and so they think, oh, profiling. And then it turns out it's this program is slow because it's waiting on some other program, like maybe a database. And a profile will not show you that. A CPU profile in Go will show you the time it spent on CPU actually doing things. So maybe reading the results back from the database. So that's one to watch out for. I mean, the simplest way to watch out for it is just watch your CPU meter. If it's ticking along at sort of 0.1 CPU usage or something like that, then it's very unlikely that profiling is going to get you anywhere. Whereas if your CPU, if the fans are all running and you 18 CPUs going in parallel, then that's probably a good one to point the CPU profiler at. I don't know what else. So I guess the next thing is it's almost always memory allocation that in Go that is causing. If you do have a CPU problem, look at the memory profile. Is my next top tip. First of all, make sure you have a CPU problem. And secondly, don't look at the CPU profile. Look at the memory profile. Look at the it's called there's 4 different profiles that come out of the Go memory profiling, and the one to look at is called alloc_space. In use space is the one to look at if your program is crashing because it's out of memory. And the other two are in use objects and alloc objects. People think that the number of objects they've allocated is going to be the thing, right? I've allocated millions, billions of objects. Surely that must have a cost. But it turns out that the Go garbage collector is really very, very efficient at allocating any number of individual objects. And what's actually slow is tracing all the pointers in those objects. So actually the cost of memory allocation is much more driven by the space that you allocate, because that space generally has pointers in it, pointers to it. And so alloc space is the one to look at if you have a performance problem. And then only once you're utterly convinced that your memory allocation is really well optimized, go back and look at the CPU profile and see what else is going on.
Yeah, they're good tips. The other one I think is for tracing as well. Sometimes it's possible that you sort of trace the wrong bits. There's another gotcha. So you mentioned thinking about where the actual problem is. I saw a case once where we didn't. We basically just had the tracing set up, but it wasn't capturing the expensive bits, and so everything looked fast, even though in practice it wasn't. This was before Go though, because I think the way that you do that in Go, I think is probably all right with that.
Because you can get kind of dark space in a trace. Hopefully, will have a big long light. If something took 5 minutes to run, you'll have a bar in your tracing view that's 5 minutes long. And then the problem you might have is you don't know what happened in those 5 minutes.
Right.
And probably it was waiting on something else. But if you don't have a trace for that, if you don't have some indication of what was going on, we do at Grafana we have databases for all these things. We have as part of the Grafana Cloud product, and so if you have both traces and profiles, it will actually bring up the profile in a tray under a trace. If you're looking at a trace, it'll just automatically do that. You don't have to ask for it. And I mean, it surprised me the first time I saw it, but suddenly I've got a profile in the middle of this trace, and so that can be really cool. But again, you have to look to see if it was actually burning CPU at that time, or has it something took 5 minutes and the GUI has presented a beautifully formatted view of 100 milliseconds. It's not where the problem is. You gotta get your got a sense of proportion. Got to look for the big fruit, as Matt.
Yeah. The biggest fruit also hangs the lowest. If I can invent a quote.
I might have to speak to HR about this, Matt.
No, it's not an HR issue. This is why we all get fired. We would just riff off this now, and it gets worse. No,
I didn't sign for that.
Okay, so this is very cool. And eBPF. So eBPF is very interesting, and I know Donia, you and the work you do, and the company you work for does a lot in this space. Is Go good? Is it a good eBPF candidate?
Yeah, I would say that. Okay, it depends what you want to observe, but let's say that eBPF and Go pair really well. I feel like eBPF. So for the people maybe who don't know what is eBPF, but it's a way to write C program, BPF programs in the kernel, in the Linux kernel, to dynamically observe or secure your kernel. So you don't have to recompile your kernel. You can just write a program, you can run it, and it will change and dynamically load on your kernel. So that's very powerful for that. But it can be very daunting and at a cost to write BPF programs. So having like Go wrappers on top of that is very interesting. So this is an aspect of Go and eBPF pairing well. And eBPF in general is interesting for observing part of your system that you can't observe easily, that you don't have access between your user space and your kernel. So that's interesting for that. I like that, personally, like something about eBPF is that you can actually access dark sides of your kernel that you can't access from the user space. So that's what I find pretty interesting. Your question was
what? Sorry, Donia.
You can access like dark sides, I call them, from your Linux kernel, like that you can't access otherwise.
Like the dark side of the moon.
Yeah.
Right.
Yeah.
Access that.
I mean, you can access part like for example, one example is like XDP, so you can access requests coming and packets coming to your laptop before even reaching your CPU. Even nothing is happening. So that's actually very powerful for that, I feel. For security especially, or that kind of thing. Or yeah, for performance too. So yeah, your question was like, is eBPF interesting to observe a Go system? I would say that today we have many tools based on eBPF in the open source ecosystem that are using eBPF and Go and plugging easily and running as operators on Kubernetes cluster running Go applications. So that's definitely pretty almost standard, I'm gonna say now. Cilium, for example, is based on eBPF and it is used as a CNI by default on most of the cloud providers now, and you have all the Prometheus metrics coming with that, and then you can just run your Grafana dashboards basically and observing your packet, your policies, what you're running. So I think that today it pairs pretty well, and it comes as default if you're running like very large distributed system on any cloud provider basically. I mean, you can run on bare metal too, but not a lot of people do that.
Yeah. Yeah, so that's very cool. So Cilium and Grafana dashboards go together well, do they?
Yeah, definitely. You have one option, and you can just export your metrics and run Grafana. Just do your port forward, and that's very easy to do. So you can, observe again like policies, networks, what's happening on your system on a network point of view, but also in terms of like requests, since you can observe like on layer 7. You have this granularity, so that's very powerful for that. And what is interesting, I didn't maybe mention it, but eBPF is running on the Linux kernel, so it's very performant for that. You're not using like, again, the user space and CPU aspects that you could use with most of the operators that you have or agents you have on today. So that's why it's very interesting. And you bypass all like the network layers. So that's very cool for that.
Yeah. So what does it look like? Are you essentially like listening to events down in that layer?
Yeah. Yeah, basically how does it work is like you have hook points on events and you have available events on the Linux kernel. So for example, if you're opening a file, you can observe any opening files on a system, or you can observe any packet incoming or outgoing, ingress and egress. So all like there is a very famous diagram of all the things that you have on the system and all the hook points that you have on memory or CPU or whatever, like all the things that's happening on the system. So, and you can hook basically anywhere. You have different hook points. I actually gave a talk like 2 weeks ago at FOSDEM about hook points and gotchas. So that can be a bit tricky sometimes. You can actually miss logs. So CPU and like context actually switching can make your system miss some probs. So you have to be careful with what you're observing and the way you're counting or observing actually. And if you run, like there is a basic command where you can see all the miscount probs on your Linux kernel. And actually, even when you're doing anything, there is a bunch of things that you're missing. So that's very, very interesting for that. So anyway, if you're doing that in production, there are some tools to see that, observe that, reattach to programs and stuff. But yeah, that can be a little bit tricky, definitely.
Yeah, I didn't realize that. There's a lot of things like that I find. That you kind of don't fully get always the full story, but it's just good enough, so it's okay. But yeah, that is kind of that is crazy that you think, oh yeah, you can just miss stuff. So. Okay, yeah. Anything else on eBPF that we want to chat about?
I think it's got its problems with Go related to the stuff we were talking about earlier, like context. So figuring out, because you start in the kernel with eBPF, and then you've got to try and figure out what was going on in this program, which first of all might not be a Go program. You've got to sort of realize it's a Go program, and then kind of hunt around for what's going on, because it's not something that's there might be a context, there might not be a context. The way that things happen in a Go program is not exposed very well to the eBPF, to it running inside the kernel. So there's people struggle with that, and Grafana actually worked on a thing that is now part of OpenTelemetry called OBI or OBI. I don't know if it's a Star Wars reference.
Probably.
Am I allowed to say that? Other space shows are available.
Yeah. We should list them just to be sure. Star Trek, Spaceballs. Okay. Yeah, there are others. What's OBI stand for? What OBI is it? What does it stand for?
OpenTelemetry eBPF Instrumentation.
Okay.
And so it should be OA. I guess that's why they went for OBI.
No, it's a good name.
So that's I guess there was a bunch of different companies working on this kind of tooling. It's not just for Go, but Go is one of the things that it does, and one of the things that Grafana Labs people were working on. So putting it in the OpenTelemetry, which is a project owned in common by the CNCF, the Cloud Native Computing Foundation. So it's not owned by any one company, all the companies can kind of collaborate on that one thing and try and improve that. So yeah, it's currently requires some very bright people to wrangle that code and get eBPF to figure out what's going on inside your Go program.
So does it add something? Does it add metadata to it so that eBPF can access that, or is it new functions that you use in conjunction with the data you get from eBPF? What does it actually do?
Yeah, I don't think it's changing anything in your code. It's looking at it from the outside and trying to figure out what's going on.
Yeah, but it's funny because I suppose eBPF is just so low level. And computers do get weird down at that level, don't they? They're quite unusual. To say that they're pure logic machines, do you know what I mean? It's meant to be a pure logic machine, but sometimes when I open a window, it just doesn't work. But surely, if everything's logical. But that's what you were saying earlier, Brian, about it doesn't take long before you have a few pieces interacting in ways where the number of possible combinations are so great that it kind of becomes almost impossible to guess what they're going to do, and it's why we need observability. But that is just interesting, I think, at the very least.
Now I think we're in Ant-Man in the quantum realm.
Right. Yeah. I mean, well, when you think of like the scale down at that level, I read a book recently and I learned about, again, I learned like a particular combination of logic gates, NAND gates specifically, make a bit. And you can it shows how you make a bit where you can store information, set information, retrieve it, and these kinds of things, just in a very mechanical way. And it is very exciting.
Matt, we're going to run out of time.
Yeah, we can't do all of it, all the way up to keyboards and mouses. So if someone's writing a library or a package in Go, do you want them to do all the instrumentation for you and just provide that? Or should they leave that to the user? It's a little bit like I like it. I always say, like, if you've got concurrency, maybe leave that out of your package. Let the user do the concurrency so they can manage it and just give them the pieces they need. Because I feel like that's easier and they get more control. What about for instrumentation? Do you think packages should provide their own instrumentation?
I would say that it depends on the size of the project again, if you're running a big project with a lot of resources, people, I would say that it can be interesting to go with your tools and have the control on what you're doing. If it's not the case, if you're running a big, like a small project, or if you're just starting somewhere and you want to have something out, I would go with built-in libraries, and have everything baked if possible, just to go straight to the point that having an app running.
Yeah.
So yeah, at the end it depends where you are in the project, I would say, but it comes with a cost all the time. It has to be a trade-off.
Yeah.
And it is one of these things that historically was not well baked in the system, like logging, for instance, because the base Go log library was too naive for most people. Then people picked a third party one, and different people picked a different one, and it basically got to the point where you the only thing, basically libraries would not log, I think was the most common reaction to that.
Right.
So I think because so many people have congregated around OpenTelemetry for tracing, certainly, that we're in a better place there. And the previous standard Open Tracing, you can put in a bridge to turn that into OpenTelemetry. So that's a situation where it's definitely better if the library does its own tracing. But there's still questions. Like sometimes it does too much, sometimes it does too little. That's what I find, that I'm sometimes frustrated that I'm getting way too many kind of low level traces out of. Just a simple example in OpenTelemetry itself, they give you a way to trace HTTP calls that your program might be making, so that's nice. And the standard behavior is you get tracing span, so each one of these comes out as a different line on your GUI. There's one when it opens the connection, there's one when it makes the DNS request and gets the address that's going to talk to, and then there's one where it starts talking on the connection, and then one where it gets the first bit of data back from the other end. And you end up with like 5 lines for one call. And helpfully there's an option. You have to know about this, but in the OpenTelemetry HTTP tracing library, you can ask it just to put those points in time down as what are called events within the one span.
Right.
And so that's another tip. But the basic idea applies to every library. You're never going to satisfy everyone. Some people are going to think you've got too much detail. Some people are going to think you've got not enough detail. So you effectively need a kind of a verbosity. How much tracing do you want out of this library? I think that's going to be the next level of convenience that people want.
Do you know why the Go team waited for so long before having slog out and waiting? So my hypothesis is that they were waiting for third parties and big companies writing libraries and then take all their ideas and have something at the end simple and just steal everything. Is it true? Or they were just not in the priority of the Go team?
I was going to say there was a talk at GopherCon UK that I went to 2 years ago, and about structured logging, the slog library, and the name of the person who gave the talk is escaping me. But
was it Jonathan Amsterdam?
Yes, there you go, John. I knew it was Jonathan. I forgot
that name does not escape me because it's one of the coolest names I've ever heard.
Yeah,
it sounds like the kind of name I'd come up with, like, to get out of trouble as a fake name. They're like, "What's your name?" And I'm like, "I don't know, Jonathan Amsterdam," something like that. But yeah.
So I can recommend that because Jonathan worked on the slog library and he talks quite a lot about the backstory. I think the basic reason why wait so long is priorities, right? The Go team is quite small. The team that's funded by Google, and they have essentially an infinite list of things that people might want, whether they want faster compilers or better observability or templates, or so many things that people want. And so at the end of the day, it comes down to priorities, and a little bit, do they have a good idea? So I think your point about being able to look across the landscape of third-party solutions that people have come up with and kind of cherry pick what seemed like good ideas was there's definitely a benefit to waiting for that to happen.
Yeah.
So I think that's what goes into why did slog take so long to... Why was it such a slog?
So generic or more important than slog at the end.
Yeah, I'd have to agree with that. Yeah.
Well, I suppose you could always be doing the slog stuff yourself, and there were third parties that let you do structured logging.
Yeah, definitely.
Yeah, but yeah, I like that they wait and see what emerges and then pick from the best. Yeah, it's harder for them because once they've made decisions, they're sort of baked in to some extent.
Yeah.
So they sort of do have to be a bit more careful, don't they?
Yeah, it's a one-way door situation. Although there's always a lot of exciting things to look at in either Go debug or Go experiment settings. That I always think that's worth a look. Each time a new version of Go comes out, take a look at what's there as an experiment, because that's probably something that they're going to put into the next version or the one after. And you turn it on through the Go experiment setting, and you get to play with it and feedback.
Yeah. Okay. Cool. Well, talking of feedback, let's end on what we want Go to change so that it makes our lives easier when it comes to observability. Are there things that we wish was different in Go? We talked a bit about some of them. Context being automatic is one option potentially. Any others? Bryan, you had an idea about actually printing out a struct properly, didn't you?
Well, that was in the debugger, which I suppose is another slant on observability. But I use the debugger in VS Code, which is a thing called Delve. Really is the debugging tool under the covers, and it makes certain decisions how things are going to be drawn. And this, in a really big program, those get frustrating. So I would love more flexibility in, and it's probably more in the debugging tool than in Go itself. Although it might be something that goes into, for instance, a struct tag. Just a simple example, you might have something that's a slice of bytes, and when you're looking at the debugger, should it be printed out as a string, as a hex number, as a series of decimal number? Does it mean something else? Is it an IPv6 address? Donia knows all about those. So that kind of being able to a little bit more semantic information somewhere to tell the debugger, and then have the debugger show it to you in a much more convenient way. That's what's on my wish list.
Could it not just be a custom type with its own string method?
Well, the debugger doesn't really want to call into a function, like a string. Yes. I mean, technically it could call the string function. So right now it will really try to avoid that, because there's no way to just call one function and come back out. What you have to do is fire up the whole Go runtime, including background Go routines, including the garbage collector. So you can't just do a simple thing. What seems like a simple thing, just call the string method. Very simple, nice, neat idea. The amount of work required for the debugger to do that is absolutely unthinkable. Now the
Is it?
the runtime, the Go runtime could conceivably add a concept of just call a simple method that doesn't, nothing running in the background, no garbage collector running. Conceivably, the Go runtime / compiler could add that concept and then make it easier for the debugger to do that thing. But yeah, the one thing that seems like really easy and obvious is utterly impossible where we are today.
Well, there we go. That sounds like a place to improve. Any other ideas for things we could where Go could get better?
I have two things. One of them builds on what Bryan was just talking about, talking about panics before. Like, one thing that would be really helpful is if you could say, like, when you put it out a stack trace, rather than giving me the pointer address of this pointer, print out this value from that struct. Because, like, for example, I spent a lot of time looking at queries that users send us. Really useful to know what the panic was and what the query was, like, what was the expression that they sent us, instead of getting a random memory address that means nothing to me. That'd be really helpful to be able to debug that problem. The other thing, that's kind of related, is errors, and being able to get a stack trace reliably for an error. So when I'm looking at, like, something went wrong, I mean, that's great. But, like, it'd be great to know exactly where that came from, what was the thing that called that, what was the path they took to get there, because that's often really helpful context to work out why it broke or why it did what it did. And yeah, that could be quite tricky to do at the moment with Go.
Yeah, they feel surmountable, are they?
I know Bryan will probably tell me that there's some wonderful edge case that makes it really tricky.
You're right. It builds on some of what I was talking about, but possibly yours is more surmountable.
Yeah.
Awesome. I look forward to seeing that next Go release then.
Of course, yeah, Go is open source. People can contribute. So, yeah, and they do. Okay, well, there we go. Unfortunately, that is all the time we have today. Thank you so much for listening, and thanks to our guests, Bryan, Charles, Donia, and we'll see you next time on Grafana's Big Tent.